right, welcome class to our first lesson of the year. We are in the red packet, Algebra 2, Chapter 1, Fundamentals of Algebra. So please, as we are doing this lesson, follow along and write down the notes as if you really would be in class. So let's start with 1.1, the real number system. So we're going to define the following terms in our notebook. So let's start with a set. A set is a collection of numbers. So when I'm talking about a set of numbers, I'm basically talking about a bunch of numbers. A set of numbers can be defined as real numbers. Real numbers are a set of a certain type of numbers. And the real number system contains all irrational and rational numbers. Okay? So real numbers are basically the whole set of numbers that we deal with in algebra. Later on in math, you will be seen in different courses, you will see numbers that are not real, okay? But for this class, we will always be dealing with real numbers. So irrational numbers. Irrational numbers are numbers that are crazy. So like the word irrational, like if somebody was acting nuts, you would say, well, their behavior is irrational. Irrational numbers are the same way. So irrational numbers, they never repeat, they never terminate, that means they never end, and they cannot be put into fraction form. So the biggest irrational number that I feel like always comes to my mind first is pi. Pi is an irrational number. So the definition, irrational numbers, they never terminate or repeat. And they cannot be put in fraction form. So the biggest example for that would be pi. A rational number, however, does terminate or it does repeat, and it can be put in fraction form. So it's the complete opposite. The biggest part of rational numbers is the word ratio in the word rational. So the word ratio means fraction. So rational numbers can be put into fraction form. And some fractions do repeat numbers, and that's okay. Some fractions terminate, and that is also okay. So basically the definition for rational numbers is that the number can be put into fraction form. So we have all of these numbers that are considered real. Within the real number system, it breaks it up into two separate sets. If you're a real number, you're either irrational or rational. So within the irrational number set, there's not a lot of subcategories. However, in the rational set, we can split it up into integers, whole numbers, or natural numbers. Integers are the numbers we love to deal with, right? They don't have any decimals or extra fractions. They're just nice numbers to deal with. So integers are your numbers on the number line. So on a typical number line. So they're your number line numbers that have no decimals, no fractions. Essentially, they are the whole numbers and the negative whole numbers. Okay, so examples of integers: -3, -1, 0, 1, 2, 3. All of your typical number line numbers that don't have any decimals or fractions would be considered an integer. Negative numbers are okay, 0 is okay, positive numbers are okay. Whole numbers. So whole numbers are like integers, but there are no negative numbers in this category, in this subcategory, in this set of numbers. So whole numbers begin at 0. And all of the whole numbers are no decimals, no fractions. So they're just like your nice nice easy counting numbers. So beginning at 0, and then it goes 1, 2, 3, and so on. Your natural numbers were the very first set of numbers that were created. So back in the day, cavemen created numbers. They were looking at rocks. They looked at a rock and they saw one rock. Then they would grab another one, and then there would be 2 rocks. So natural numbers start at 1, and these are your counting numbers. So it starts at 1, and then it goes on. So notice, integers, whole numbers, and natural numbers all kind of intertwine. We have to understand that natural numbers start at 1 and then go on to the positives. Whole numbers start at 0 and then are all the positives. Integers are all of the whole numbers and also the negative versions of whole numbers. So what I have here is a number system graphic organizer that we are going to complete. But I want to give you some time to write all of this in. So I'm going to stop the video and then we will resume.